Okay, so the first thing I want to go over is real quick is this, the idea of factors and that sort of thing. So if I were to ask you to divide, 4 into 63, right? You would determine that 4 goes into 60 15 times, and then the difference is 3, and therefore, since 4 doesn't go into 3, there's like a remainder. So the remainder is 3. So you would say 4 is not a factor of 63. Obviously, if the remainder is 0, then 4 would be a factor. Okay, so this is the first important idea. So what happens if you're trying to divide like x minus 2 into 2x cubed plus 3x minus 4? Right? Well, first thing you want to recognize is that I left out the x squared. So you definitely want to kind of rewrite this question before you do long division. So you don't want to have any missing terms when you're doing long division. Otherwise it messes up your placeholding. So we'll put in a little placeholder for x squared there. Hopefully you remember kind of how to do this. You're really just starting off with the question, what is 2x cubed divided by x? So this is the first thing you ask yourself. What's 2x cubed divided by x? So what's the answer to that? 2x squared, right? So just divide that real quick. Forget the 2 here. Forget this stuff over here. Just looking at the leading terms, the ratio here is 2x squared to 1. So that becomes the part, like the first part of your quotient up here, 2x squared. All right. And I usually do this in pencil because there's a lot of erasing. Okay, now I'm going to take that and multiply by this binomial in front. So what is 2x squared times x minus 2? It's 2x cubed minus 4x squared. And as you know, in long division, we always then subtract. Okay, what's 2x cubed minus 2x cubed? Just 0. What is 0x squared minus negative 4x squared? Yeah, so we're effectively adding here. So some people like to actually cross this out and make it a plus and then change these signs inside here. I never really do that, but if that helps you, great. But we are basically just adding that 4x squared after all. In any case, this comes out to 4x squared. And then you drop down the plus 3x like that. And you kind of start all over again. You ask yourself, okay, let's start over. Back to the drawing board. What is 4x squared divided by x? So now you're asking, how many times does x go into 4x squared? Okay, so what is the answer to that question? 4x times, right? So you put that up here. And you multiply like that. Oops. And then you write your result. So what is 4x times x minus 2? Should be 4x squared minus 8x, right? And you're trying to subtract, so you effectively add that 8x, and you get 11x. You drop down this negative 4. And you're kind of on stage 3 of your division, so you're going to now ask, how many times does x go into 11x? So what do you multiply x by to get 11x? 11, right? So that goes at the top. And then multiplying 11 by x minus 2 just gives us 11x minus 22. But we are effectively adding that 22, as we said, so you're just basically going to get 26. I'm sorry, it's actually going to be 18. Negative 4, and you're adding the 22. Okay, so what is our final conclusion? Our conclusion is that the remainder is 18, and we determine, look, x minus 2 is not a factor. Okay? So x minus 2 is not a factor
of 2x cubed plus 3x minus 4. So all that work just to show that x minus 2 didn't divide nicely, there has to be a better way to do this. Okay, so somebody came along and invented what's called synthetic division, which is a little bit faster. So this is called long division, as you know. But there's a faster, more elegant way to do this. You can take your divisor here, x minus 2, and just solve it for x. So just set it equal to 0 and solve. So what do you get if you solve this for x? X equals 2. And then what you do is you do sort of a pseudo division. It's like a fake division almost, where you put 2 in a box like this, and you just list the coefficients. So we have 2, that's for 2x cubed, and then we have the 0, that was for the 0x squared, and then the 3 and the minus 4. Just list the coefficients. So we're talking about the numbers in front of the x's. 2, 0, 3, negative 4. Just write down. That's a little bit easier, less writing. And then you draw a line under it, like I did. You put the 2 in the little box up here. This is the green 2 from the left work there. Okay? And you actually start the problem off by just dropping this 2 down like that. Okay? So we're just going to start off here. We haven't done any work yet, but you kind of get it all set up like this. Okay, so what you're supposed to do is start off by multiplying what's at the under this line by what's in the box. So right now we have a 2 under the line. So what's 2 times 2? Obviously 4. Okay, so that goes here. And then what's 0 plus 4? So you're adding straight down. You see 4, right? Now multiply that by what's in the box. So what's 4 times 2? 8, right? Put that here. Add straight down. What's 3 plus 8? 11, right? And then multiply that by what's in the box. So it's 11 times 2? 22, right? And then adding straight down, what's negative 4 plus 22? 18. Okay, so what is this? This actually represents what you see up above. This is the 2x squared plus 4x plus 11 quotient. And this is the remainder, 18. It's the same answer we got using long division, which you have to admit it's a little bit less writing. 2x squared plus 4x plus 11, remainder 18, same thing I had up here, less writing, much simpler. Okay, so we're grateful for whoever invented synthetic division. The only thing that's a drawback about shortcuts like this is they don't always work. So this works great when you're dividing by x minus 2, but it would not work great if you're dividing by, let's say, x squared minus 2. Synthetic division is not the right choice for the job. You would want to use long division in that case. My computer's going to continue asking me to reboot, and I will keep saying postpone. Okay, so everyone see how we do the synthetic division? Raise your hand if that's brand new. Okay, so you'll get plenty of practice with it. It'll be one of your really solid skills. Now there's a really fast way to get remainder, even faster than both of these. Let me show you what that is. So there's the title for this. This is called synthetic division. Nice, fast method there. But there's this other thing called the remainder theorem. Okay, and the remainder theorem is the fastest of all. And what it says is, you take your x minus 2, that's your divisor, you set it equal to 0 and you solve, and you get 2. But instead of doing division like we did above, we're just going to take 2 and plug it into the polynomial. So here was our polynomial, f of x. It was 2x cubed plus 3x minus 4, remember? Just find f of 2. Simply find f of 2. Watch what happens. F of 2 is 2 times 2 cubed plus 3 times 2 minus 4, which is 16, plus 6 minus 4, which is 18. Notice that that was really fast, all it gave us is a remainder. It didn't give us the nice quotient like the last two methods gave us. See the answer in blue at the top of the board? We didn't get all of it, but we did get the remainder number at the end. So if that's all you're interested in, the remainder, by all means, this is the fastest way, remainder theorem. Okay? But don't expect to get the 2x squared plus 4x plus 11 from it. It's only good for finding the remainder. And what does it mean that the remainder was not 0? X minus 2 is clearly not a factor. So we've seen that 3 different times in this problem. If someone ever asks you, is this a factor? I think you should use the remainder theorem. You'll be able to find right away whether or not it's a factor. Okay? It's pretty simple. Okay, now if it is a factor, then of course you've just begun the process of solving the problem, right? But if it's not a factor, at least you know it good and early and you can try some other numbers. So let's go ahead and try a different problem. Let's say that you're given this problem here. Find the real zeros of f of x equals 2x cubed plus 11x squared minus 7x minus 6. This is a minus sign here. No, I want to use a plus there. Okay, so see, if it's not factored, then how are you going to graph it, right? Think back to my worksheets. In my worksheets, I pretty much had everything factored for you, which made the worksheets not that hard. You know, you can at least get the roots. But if it's not factored, you've got to factor it. So how do you begin factoring this? Well, it seems like we're really just looking for numbers that make this 0, right? So you can try plugging in various numbers and see if you can get it to come out to 0, okay? It's actually not that hard to do. Sometimes it's not possible to do that, but on this problem it's pretty easy. There are 3 nice numbers that make this 0. But nobody really wants to do guessing completely, right? There's an infinite number of choices for numbers to plug in. Like, should I plug in 1? Should I plug in 4? Should I plug in 1/2 or 2/3 or 15/7? Like, what am I supposed to plug in? I don't know. Well, could be none of those. Could be 99/3, or how about 99√3? What if your answer was that? Okay, so there has to be a way to kind of narrow it down from an infinite number of choices here. So what we do is we take the factors of this number here. What are the factors of 6? What numbers go into 6? 2, 3, 6, what else? What goes into every number? 1. So these numbers, we call these the p-values. They are the factors of your constant. Okay? Okay, now you come over here and you look at this leading coefficient. So what are the factors of 2? 1 and 2, right? These are called the q values. Okay. Now what you do is you make a list of p over q's. P over q options. So I'm just trying to divide p and q into little fractions. So here are some possibilities. We could do 1. We'll just choose 1 here. We'll do 1 over 1 and 1 over 2. So 1 over 1, 1 over 2. Or if we go with this 2 right here, we could do 2 over 1, 2 over 2. That's a possibility. Or if we go with this 3, it could be 3 over 1, 3 over 2. Or lastly, the 6. 6 over 1, 6 over 2. So just basically was dividing each of these p's by the 2 q values. 1 over 1 and 1 over 2. 2 over 1 and 2 over 2 and so forth. So I came up with a total of 1, 2, 3, 4, 6, no 8 different options, you know. All right, fair enough. All right, now, it is possible also that negatives might be involved somehow, right? I asked you what are the factors of 6, and you guys said 1, 2, 3, and 6. But also negative 1 divides into 6. 6 divides into 6, but so does negative 6. So we should also probably put like a plus or minus on each of these. Okay, so here are the only possible rational roots that exist in the universe. plus or minus 1, plus or minus a half, plus or minus 2. This is just redundant. Plus or minus 3, that's from the 3 over 1. Plus or minus 3 halves, plus or minus 6. And this one here, 6 over 2, that's redundant. We already have 3, so don't need to repeat it. So altogether, there are a total of 12 possible numbers that are nice and clean, crisp rationals. And if this problem has rational roots, then they are right in front of you right here. Now, if the roots of this thing are like rad 3 and negative rad 3, or 4i and negative 4i, then we're going to find out that this is a big dead end. But if the answers are nice, clean, rational values, they are sitting right here. So that narrows it down from an infinite number of guessing numbers to just 12. Okay, so let's get started. The first thing in my list is positive 1. So I'm going to jump right in and do synthetic division. I put a 1 in the box and write 2, 11, negative 7, and negative 6. Notice I'm not missing anything here. I've got a cubic, a quadratic, a linear, and a constant. So we're good. We'll start off just by bringing the 2 down. Okay, let's begin our synthetic division work. So 2 times 1 is 2. Adding, we get 13. 13 times 1 is 13. Adding, we get 6. 6 times 1 is 6. Adding, we get 0. It looks like we stumbled across our first answer almost right away. Don't expect that to happen very often. Okay, that was a huge success. X equals 1 is a root. And x minus 1 is a factor. Good news. Okay, so what does this all mean? This means that original polynomial, 2x cubed plus 11x squared minus 7x minus 6, that thing was ugly, but we're starting to get it broken down now. We now know that this can factor into x minus 1 times something. Good news. And that something is just sitting right here. That something is 2x squared plus 13x plus 6. Which factors again? Correct. Okay, so all in all, this thing fully factors down into x minus 1 times 2x plus 1 times x plus 6. Fully factored. Okay, so this is kind of how we handle cubics, because when you learned how to factor, the hardest ones you learned how to factor in Algebra 1 were things like this, where the a value is like 2 or 3 or something. And you had to kind of do like guess and check, or some people have these fancy methods. But listen, with a cubic, most people just start off right away with p and q options, and then they come up with one that works, and then they factor from there, because now it's only quadratic, see? So they can use their old Algebra 1 for tricks. I don't really have any tricks for factoring this last part, guys. So I appreciate all the clever little things your teachers have taught me in the past to go from this step to this step, but I don't use any of that stuff. I just try to guess numbers and language to figure it out. Okay? If you need a tutorial on how to factor this, feel free to go online and look up the crisscross method. It's pretty good. It's pretty easy to learn. Or just bust out the quadratic formula. The quadratic formula will give you the answers as well. Right? Okay, so what are my 3 roots for this problem? Because that's what we were asked for. Final answer, x is 1. X equals what? Negative 6, that's true. And this middle term yields x equals negative 1/2, right? So these are the 3 roots to this problem. You can even graph it now, like you did on the worksheets. You could actually graph the polynomial, which is really powerful. We didn't know how to maybe do that before. So pretty big stride forward from last year. Okay, so there's your answer to the first one. Now, obviously I got really lucky on my first synthetic division. That is not always going to happen. Let's put our cell phones away, okay? Okay, let's try another example. This time we're going to do one that has some fractional coefficients. So we'll talk about what to do with that. Let's say that you're given x cubed minus 2/3 x squared plus 3x minus 2, and this is set equal to 0. The instructions on this would probably say solve. Solve, right? Not factor or find the roots. Although you might still be asked it in that way, it's most likely to just say solve, because it's an equation now. So what you would do is you kind of just repeat the process, but I would suggest you get rid of the fractional look first. So let's just multiply everything by 3. So this becomes 3x cubed minus 2x squared plus 9x minus 6 equals 0. And then what I would do is just do the PQ process again. So P are the factors of 6, so that's 1, 2, 3, and 6. You can put plus or minuses in for those two if you want, or just save it for later when you do the P over Q's. And then we have basically the Q values, which are 1 and 3. So if you're going to make a list of possible rational roots, you're going to basically have plus or minus 1 over 1, right? And then we have plus or minus 2 over 1, and plus or minus 3 over 1, and plus or minus 6 over 1. And we also can have a denominator 3, so we could have plus or minus 1 over 3, plus or minus 2 over 3, and plus or minus 3 over 3, which is actually redundant. We already had that earlier when we put plus or minus 1. And lastly, plus or minus 6 over 3. But that's also redundant because that's the same thing as plus or minus 2. Okay, so we ended up with these values. Our P over Q options are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, and plus or minus 1/3, and plus or minus 2/3. All right, so let's begin our synthetic division. We have 1, negative 2/3, 3, and negative 2. Nothing's missing in this problem in terms of the polynomial. We have our cubic. I'll underline them up top here. We have our cubic, our quadratic, our linear, and our constant. So we're not missing anything. We'll just start with 1 in the box. Why not? If you plug in 1 in the box, you're multiplying, you get 1, 1/3, 1/3. This doesn't look too promising. 10/3. I think we should scratch that. You'll notice something about this answer, though. If you are actually pursuing it, this comes out to 4/3. You'll notice that every one of these numbers is positive. See that? So I just did my synthetic division, and I just noticed there are no sign changes at all in my final work there. I have a 1, a 1/3, a 10/3, and a 4/3. So all are the same sign. This is a very interesting thing. What it really means is this, listen very carefully, that we already, by choosing x equals 1 as our first candidate, that number, x equals 1, is already too big. It's already too big. Okay? So let me just summarize that by saying, or let me say this then. In our list of possible P over Q's that we created, we had these options. I'll just write them here. We have 1 and negative 1 and 2 and negative 2 and 3 and negative 3 and 6 and negative 6, right? And 1/3 and negative 1/3 and 2/3 and negative 2/3. These were all possible at one time. But we just tried 1, and 1 didn't work. In fact, it gave us all the same sign, quotient and remainder. The whole thing was positive. So that means that 1 didn't work, but 2 will not work, 3 will not work, 6 will not work. Why? Because 1 is already too big. It's only when we see sign changes that we know we should continue guessing up the number line. So we're done with those values. That narrowed it down pretty quickly. Okay, so if it's not 1, then what is it? Well, the only positive choices I have left are 1/3 and 2/3 left. Okay, so let's go and try 1/3 real quick. 1/3. Okay. So let's do multiplication. Adding, I get 1/3. Multiplying, I get 1/9. Adding, I get basically 27/9 plus 1/9. This is 28/9. That didn't work. And then 28/9. This could be 28 27ths or something. This didn't come out to 0. That did not work. Okay, my only other candidate is that 2/3. Let's try that real quick. All right. By the way, if you don't like using the fractional coefficients that we've been working with, you can also go back and you can use these coefficients instead if you like. The 3, the -2, the 9, and the -6. That's up to you. I'm still using the fractional ones, but it doesn't matter which you use. What mattered was when we first made our P over Q list, we needed to eliminate fractions to get the P over Q's figured out. Okay, so let's go to synthetic division. Multiplying, we get 2/3, and adding, we get 0. That's always interesting. Multiplying by what's in the box, we get 0, and adding, we get 3. Multiplying by what's in the box, we get 2, and this comes out to 0. So this is my remainder. This is my quotient over here. This means 1x squared plus 0x plus 3. In other words, x squared plus 3. So 2/3 is a factor. Interesting. I'm sorry, 2/3 is a root. So x equals 2/3 is a root. Interesting. All right. And x minus 2/3 would then be a factor, by the way. But this is one answer. And if we want the other answers, we can just look at the fact that we're left with 1x squared plus 0x plus 3. In other words, x squared plus 3. That is our other factor. So what we're saying is this original problem, if you go back to it, it was x cubed. Let's just rewrite the whole question. This was the original question, remember? And normally when something's equal to 0 like this, we try to factor it to figure out the roots. Well, we just figured out that x minus 2/3 is a factor. So x minus 2/3 is a factor. The other factor is x squared plus 3. So we've already determined that x equals 2/3 is an answer. To get the other one, we would try to solve this portion. Unfortunately, that portion is not going to give us any more real roots. Okay, so in section 3.8, we'll deal with those types of answers that have I in them. But for now, in 3.7, the question always says find the real roots. So if you try to solve this, you end up with non-real results. Non-real results. Okay, so the answer is 2/3. If you want to write down the imaginary answers, you can, but just know that I'm only asking for real ones this time. X would be plus or minus I root 3. That's a 3.8 concept though. So my answer's in black right there. Now how did I know there was even going to be an answer? Suppose I had tried all my x's and they had all failed. Well, that could never happen on a cubic. Let me show you why. So this problem is a third-degree polynomial, right? And so a third-degree polynomial actually has to cross the x-axis at least once. So let's draw a picture of a third-degree polynomial. What does a third-degree polynomial look like? It has one end behavior going up and one end behavior going down. In other words, one arrowhead going up, one arrowhead going down. So it's impossible for this graph to completely avoid the x-axis, right? That's not possible. So let's take a look. So imagine trying to connect these two arrowheads together. You're going to have to cross through the x-axis at least once. See? It could be here, it could be over on the right. Or maybe if being a cubic, there's actually 3 crossing points. That happens too. So 1, 2, 3. In this particular problem, there's only one answer, and it was at 2/3. So it's really a graph more like this. It crossed at 2/3 and nowhere else. And there might be extra wiggles in here, but no more roots. Okay? We could have up to 2 turning points. The way I'm sketching it, there are none. But that's not our focus right now, right? Our focus is roots. on today's lesson.